Okay, we now get to section B of mathematics, paper 2, which was done in the year 2019. And here is the question we have. So we are going to answer the first term of an arithmetic progression AP is equal to the first term of geometric progression. The second term of the AP is equal to the fourth term of the GP, while the 10th term of the AP is equal to the 7th term of the GP. So given that A is the first term and D is the common difference of the AP, while R is the common ratio of the GP, we need to write down two equations connecting AP and the GP. Then from there, we find the value of R that satisfies the progression. Then part C, given that the term of the AP is 5120, find the value of A and D. Then now we can begin and work it out. So the first thing we have been given the first term of the AP equal to the first term of the GP. So that means we can find the two equations. So one thing we need to note that the nth term of AP is given by A plus n minus 1 multiplied by D, and the nth term of GP is given by A times R power n minus 1. And let us check for the AP and that for the GP. What we compare those terms which are equal. So second term of the AP is equal to the fourth term of the GP. So let us get the second term of the AP. First term is A plus second term n is 2. So 2 minus 1, that is 1 times D. So that is the second term for the AP. So is equal to the fourth term. So the fourth term, T4, for the GP is given by A. In this case, n is 4. So that is A times R power n minus 1. N is 4. 4 minus 1, that is 3. Then again, the other information we have, while the 10th term of the AP will be given by A plus n is 10. 10 minus 1, 9. So 9D plus 9D is equal to the seventh term of the GP. The seventh term of the GP is given by A times R power n minus 1. N is 7. 7 minus 1, that is 6. And therefore, now we need to form those two equations. So second term of the AP is equal to the fourth term. Second term is A plus D is equal to the fourth term of the GP, R A times R power 3. So that is the first equation. Then the other equation, the 10th term of the AP is equal to the 7th term. So 10th term is A plus 9D is equal to the 7th term of the GP, which is A times R power 6. So that is for the first question. Then part B of the question, part B, find the value of R that satisfies the progression. So we need to find the value of R, and how do we get the value of R? We actually, the two equations we have formed, we solve for A and D, and then we look the value of R which will satisfy the two equations. That is So the first equation, we can write d in terms of a and r, and that will be d is equals to ar power 3 minus a. Then call this the third equation. So we are going to substitute the third equation into equation number 2. So that will be a plus 9, where we have d substitute with a r power 3 minus a, then plus, then will be equal to a r power 6. So we can expand, open the bracket. So we have, this is a plus 9ar cubed minus 9a is equal to a r power 6. So we can rewrite them as a r power 6, then minus 9ar cubed, then a minus 9a, so this will be the other side minus plus 9a minus a is equal to 0. So let us simplify it. We have ar power 6 minus 9ar power 3. This will be plus 8a is equal to 0. So for this case, now we can divide a throughout since a is common. So we shall have a r power 6 minus 9r power 3, then plus 8 is equal to 0. We can say let r power 3 equal to a value, say x, and therefore we shall have, this will be the same as r power 3 squared minus 9r cubed plus 8 is equals to 0. So we have x squared minus 9x plus 8 is equals to 0. We have formed a quadratic equation, and therefore we need to solve for the quadratic equation. So the product, I'm going to use factorization method. Product is 8, 1 times 8. Then we need to get some factors such that the sum will give us minus 9. And therefore the factors of 8 will be minus 8 and minus 1. If we add the two, we get minus 9. So we write minus 9x in the expanded form. That will be x squared minus x minus 8x plus 8 is equal to 0. Therefore, we can factor out here x, take into pairs and factor out what is common. So here x is common. So we get x, then minus 1. Then here 8 is common, minus 8. So factor out. So we have x and minus 1 is equal to 0. Therefore, x minus 8 multiplied by x minus 1 will be equal to 0. Either x minus 8 is 0, or x minus 1 is equal to 0. Therefore, x is equals to 1 or 8. But we said let r power 3 equal to x. So when x is 1, r power 3 is equals to 1. And this implies that r will be the cube root of 1, which is 1. The other case, r power 3 is equals to 8. And therefore, r will be the cube. To get r, find the cube root of 8, which will be 2. Therefore, we need to consider which one satisfies the progression. Is it 1 or 2? So we can use our value of d here and get it. So when x is when x is, r is 1, substitute here. When r is 1, so we shall have a times r power 3 is 1, so a minus a, that is 0. There is no way in this progression constant, common ratio will be 0. And therefore, we also consider the other case when r is 2. So d is, so a times r is 2, r cubed 8. So we have 8a minus a, which is 7a. So in this case, r satisfy the progression, r is 2. Then part C of the question, given that the 10th term of the GP is 5120, find the value of a and find the value of a and a and d, and therefore for the nth term is given by a times r power n minus 1. So the 10th term n is, this case is 10. So term is 5120 is equals to a times r is 2. We got r is 2. So raised to 10 minus 1, that is 9. Therefore, a will be equal to 5120 divided by 2 raised to 9 is 512, and therefore we get a is 10. The same way we can get for d, substitute for d into this, that is ar power 3 minus a, this case a is 10 times 2, r is 2, 2 power 3 minus 10. This is 80 minus 10, d is 70. So we have the last part D of the question, which is calculate the sum of the first 20 terms of the AP. The sum of n term of AP is given by n over 2, bracket multiplied by open 2a plus n minus 1 d. And therefore, the sum of the first 20 terms is given by 20, n is 20, so you have 20 over 2. Then you have 2 times a is 10, then plus n is 20, 20 minus 1, that is 19, multiplied by d is 70. So we get this will be 10, 20 plus is 13, 30. So if we work it out, we have 10 multiplied by 20 plus 1330, we get 1350. And therefore we end up getting 13,500. That is the sum of the first 20 terms of the AP. Our next question is question 18. And in question 18 says Mbaka bought some plots at 400,000 shillings each. The value of each plot appreciated at the rate of 10% per annum. So we need to calculate the value of a plot after 2 years. Then part B of the question, after some time t, the value of plot was 558,400 shillings. Find t to the nearest month. And then part C, Mbaka sold all the plots he had bought after 4 years for 2,928,200 shillings. Find the percentage profit mpaka made, correct to 2 decimal places. So we need to begin from part A, and that is mpaka bought some plots at 400,000 each. The value appreciated at the rate of 10% per annum. So we need to calculate the value of the plot after 2 years. So using the compound interest formula, we shall get the amount after 2 years will be given by the principal amount P multiplied by 1 plus R is the rate of 100 multiplied by raised to power n, where n is the number of years. So in this case here, principal amount, that's what he bought the plot at, 400,000 each. Then the rate per annum is 10%, and n is after 2 years, n is 2. Therefore, let us substitute into that compound interest formula. So to get the value after 2 years, the principal amount is 400,000, then multiply by 1 plus R is 10, so 10 over 100, close the bracket, raised to n is 2. So this we get 400,000 times 1 plus is 10 over 100, that is 0.1. So 1 plus 0.1, that's 1.1. Then we square it. So if you work it out, so the amount after 2 years will be 484,000 shillings. Then part B of the question, after some time t, the value of the plot was 558,400. Find t to the nearest month. So that means after time t, the total amount A was 558,400, and then we need to find t. So after time t, using the same compound interest formula, so amount is 558,400 is equal to, still the principal amount is 400,000, then multiply by 1 plus, the rate is still the same, 10 over 100 times n is t, so we need to find t. So we are going to divide both sides by 400, so we shall have 400,000 divided by 400,000. So we have this 1 plus 10 over 100, that's 1.1. That's what we have. So if you work out this, again 1.396 will be equal to 1.1 raised to power t. So to get t, we need to introduce log to both sides. So we have log of 1.396 will be equal to log of 1.1 raised to power t. So this can be written as log of 1.396 is equal to, this can be written as t log 1.1. So we are going to divide both sides by log of 1.1 divided by log of 1.1. So this will cancel, and therefore we get t as logarithm of 1.396 all over logarithm of 1.1. Working it out, we get 3.500 for significant figure. This is years, in which case can be written as 3.5 years. But the question requires t to the nearest month. So we are going to indicate in terms of years and month, and that will be 3 years. 1 year is 12 months, so a half of 12 is 6 months. So 3 years and 6 months. Lastly, part C. Mpaka sold all the plot he had bought after 4 years for 2,928,200. Find the percentage profit Mpaka made, correct to 2 decimal places. So value of one plot. So we need to get the value of one plot after 4 years. So value of one plot after 4 years will be given by the principal amount multiplied by 1 plus, in this case, we shall get, that is 585, 640 shillings. That is the value of one plot. Now, for the 4 plots, now all the plots, so he had other plots, and therefore we need to get the total number of plots he had sold. So to get the number of plots will be the total amount after 4 years, 2,928,200. We divide by the value of one plot after 4 years, 585, 640. And if you work it out, you're going to get 5 plots. So the profit made for the 5 plots, profit made, so is the total amount 2,928,200. We minus the initial or the principal amount for one plot was 400,000. For 5 plots will be 400,000 times 5. And therefore, we get 2,928,200 minus, this will be 2 million. And therefore, if we subtract, we get 928,200 shillings. So to get the percentage profit will be the profit 928,200 divided by the initial amount for the 5 plots. This will be, there are 5 plots and the initial amount was 400,000. So 400,000 times 5, that is 2 million. Then times 100%. So we approximately, to correct to 2 decimal places, will be 46.41%. So the next question is question number 19, whereby we've been given the figure KLMN. Below is a scale drawing of a rectangular piece of land of length KL, which is 80 meters. So KL is 80 meters. Then part A of the question, on the figure, on this figure we need to construct the locus of point P, which is both equidistant from L and M, and then from KL and LM. So the first step we need to take in Roman 1, we needed to, so for Roman 1, we needed to draw the perpendicular bisector of LM so that we locate the locus of point P. And therefore, so let us place here at that particular point. That is it. And then adjust the radius. We are going to put a mark there. And also we do the same on the other side. maintaining the same radius, maintain the same radius, place the pointer, use M as the center, and then we do the same thing. Put a mark there, and also on the other side we do the same. Then after that we use the ruler and we join the points with a straight line. So that is it. So that is the locus of P, which is equidistance from L and M. Again, also and from KL and LM. So for KL and LM, at this particular point, it is at 90 degrees. Therefore, we need to bisect the angle at L. So let us bisect the angle at L. So place, use L as the center. So I'm going to adjust the radius again and put a mark there, and also toward the KL. Then from there, we use those arcs as the center and adjust the radius. So put a mark toward that point, and also use the other arc as the center and do the same. Then after that, from point L, we join the intersection of the axes. That is it. So at that particular point here, that's point P. So that's where we have point P. That is the locus. Then from there, we need to find the locus of point Q such that KQL is 90 degrees. 90 degrees. Therefore, what we need to do, we bisect KL, and then the point of where we have bisected, that's the perpendicular bisector of KL, that where it cuts KL, that will be the center. Then we draw a semicircle. Again, let us bisect. We use a different color. So using a radius more than a half of KL, so I put a mark there, and also on the other side, the top. Again, I use the other side as the radius, K as the center. Again, supposed to maintain that distance, so I just have to maintain that distance again. That is it. the same toward the top. That is it. Then I use the ruler and draw that perpendicular line. So at this point is the center O, and therefore I'll use now I draw that semicircle using O as the center of that circle. So I have so that is it. Now at that particular point, now this is the locus of point Q. We have located it. Then after that, we shade the region R bounded by the locus of Q and the locus of points equidistant from KL and LM. So this line we drew here, that is the locus of point equidistant from KL and LM. All this line drew out. And therefore, this is our region. That's the region R. We satisfy that condition. So after that, now we are going to find the area of the region R in meters squared, and we take pi to be 3.142. Therefore, considering this part, this is a quarter of a circle, and we have this a sector. Therefore, we need to find the area of this sector, which is a quarter of a circle, minus the area of this triangle. And therefore, the area will be given by, so for this circle here, it is 90 or a quarter. So theta over 360 times pi r squared, then minus a half times of the triangle OL times OQ. Since up to this point, that is, these are along that region. Therefore, theta is 90 over, and now over 360 times 3.142 times radius. KL is the diameter, which is 80 meters. Therefore, OL will be 40. So 40 is square it. Then minus a half times OL is again 40 times OQ, again it is 40 since it is the radius of that sector. So if we work this out, we get 1256.8 minus, the other part will be 800, and therefore if we subtract, we get 456.8 meters squared. Next is question number 20. A ship left point P, which is 10 degrees south, 40 degrees east, and sailed due east for 90 hours at an average speed of 24 knots to point R. Take 1 nautical mile to be 1.853 kilometer and radius of the earth to be 6,370 kilometer. So we need to calculate the distance between P and R in part Roman 1 nautical miles, Roman 2 in kilometer. Then part B of the question, we need to determine the position of point R And lastly, find the local time to the nearest minutes at point R when the time at P is 11:00 a.m. or 11 a.m. So begin with, so the ship actually left point P and sailed due east for 90 hours. So what we need to do, since allow me to make a sketch, we have the equator, then point P is due east, south of the equator. So consider it's at that particular point, whereby that is point P, which is 10 degrees south, and it is 40 degrees east, and sail due east for 90 hours. So maybe after 90 hours, it has reached to a point, at a certain point after 90 hours. So the average speed is 24 knots to a point R. So to a point R. And therefore, let us calculate the distance between P and R. So P and R. So to get the distance in nautical miles, distance PR, distance is given by speed times time. And we have been given the speed is 24 knots. I want you to note that 1 knot is equivalent to 1 kilometer per hour. And therefore, the speed, which is 24 knots, I mean 1 knot is 1 nautical mile per hour. So that is 24 nautical miles per hour times the time is 90 hours, and therefore we end up getting 24 times 90, that is 2160 nautical miles. Then part B of the question, in kilometers, we have been given the conversion rate that 1 nautical miles is equivalent to 1.853 kilometers. Therefore, for 2160 nautical miles will be how many kilometers? So this will be 2160 times 1.853, and therefore we multiply it, we get 4002.48 kilometers. Then we need to answer part B of the question. Determine the position of point R. So R still, it is on 10 degrees south, and therefore we need to get, so let us say that it has taken an angle theta. So the longitude difference, let it be theta, so that we work out theta. So let longitude difference be equal to theta. And therefore, from that point, to get distance, the distance PR in nautical miles is given by 60 times the longitude difference and cosine vector. So whereby this will be our latitude difference, and therefore distance of PR in nautical miles is 2160, which is equal to 60 times longitude difference what we are looking for. Say it, longitude difference times cosine. This is the latitude difference from the equator. It is on a latitude 10 degrees. So times cosine 10 degrees. And therefore, once we work out this, we are going to get the longitude difference will be 21 over 60 cosine 10. And if we work it out, we shall end up getting that will be 60 cosine 10. We get 36.56 degrees. So that is the longitude difference. But we need to get the position of R. So from point P now, which is 40 degrees east, moving toward east, so 40 plus 36.56, we get 76.56 degrees east. And therefore, position of R in terms of longitude and latitude, that will be, it is still on 10 degrees south and 76.56 degrees east. So that is the position of point R. Then we find the local time to the nearest minute at point R when the time at P is 11. So the time at P is 11. So we need to find the local time at R. So what we need to use here is the longitude difference, and the longitude difference we had was 36.56. So for every difference in 1 degree, there is a change in 4 minutes. And therefore, for a difference of longitude, 36.56, so times 4 minutes, and therefore in hours, we divide by 60, we shall get 2 hours and that 26 minutes. So for a difference of longitude, 36.56 will give us a difference of 2 hours, 26 minutes. But points or any point toward east of the equator, they are normally ahead of time. And therefore, the local time at R will be, 00 plus 2 hours, since they are ahead of by 2 hours 26 minutes. We are going to add, and therefore we get 26 hours. So that will be the time. So 11 plus 2, so we get 26 hours. Or the time will be 1:26 p.m. Question 21. A workshop makes cupboards and tables using 2 artisans, A and B. Every cupboard made requires 3 days of work by artisan A and 2 days of work by artisan B. Every table made requires 2 days of work by artisan A and 2 days of work by artisan B. In 1 month, artisan A worked for less than 24 days, while artisan B worked for not more than 18 days. The workshop made X cupboards and Y tables in that month. So write all the inequalities which must be satisfied by X and Y. Then we are going to represent the inequalities above on the grid provided. Then after that, we answer this particular question. The workshop makes a profit of 6,000 shillings on each cupboard and 400 shillings on each table. Find the number of cupboards and the number of tables that must be made for maximum profit, and hence determine the maximum profit. So let us begin. So the workshop makes cupboard and tables using artisan A and B. So every cupboard made by requires 3 days of work by artisan A and 2 days of work by artisan B. Every table made requires 2 days of work by artisan A and 2 days of work by artisan B. So in that month, A worked for less than 24 days, while artisan B worked for not more than 18 days. So the workshop made X cupboard and Y tables in that month. So we need to write all the inequalities which must be satisfied by X and Y. So for X, represent the number of cupboards and therefore must be greater than 0. Also it can be equal to, so it can be either never made the cupboards or made more than 0, could be 0 or more. Then for Y, number of tables again be greater than 0 or equal to 0. Then for the other case, for artisan A, and you have artisan B. So for artisan A, every cupboard made requires 3 days of work by artisan A. So artisan A, within 3 days, will have made 3x cupboards. And again, for artisan A, making tables requires 2 days of work. So plus the number of tables. And for this case, A worked less than 24 days, so it will not exceed 24. So everything will be less than 24. Then for artisan B, requires 2 days of work to make cupboards. So the number of cupboards in 2 days will be 2x, then plus the number of tables requires 2 days of work. Again, so 2y. And it should not exceed more than 18 days, for not more than 18 days. So it could be 18 days and less. So that will be less or equal to 18. For this case, if I simplify this, divide both sides by 2, I get x plus y is less or equal to 9. And therefore, now whatever I'm going to draw the lines, I need to draw the line x is equals to 0 and shade the unwanted region. The same case I'll do y is equal to 0 and shade the unwanted region. Then for artisan A, it means if I divide both sides by 24, divide by 24, divide by 24. So I'll get, here it will be x over 8 plus by 2 and by 2 12, so y over 12 is equal to 1. So I also draw this and also indicate the shade the unwanted region. The other one, so this will be again divide by 9, divide by 9, divide by 9. So I'll get x over 9 plus y over 9 is equal to 1. Then this what I'm going to plot. It will make my work easier writing this in this format, so that I just indicate the x and y intercept. So I'm going to draw now. Let me draw the y-axis. Start from this point. Fine. At least it should go for y-axis, should go up to 12. So at least I can start from 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, then 0 passes through this point. The x-axis will pass through. So 0. Then for the x-axis, it's up at least to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 10. So this for x, and we have y. Now we need to draw the inequalities and show them. So x is equal to 0, the line x is equal to 0, that is the y-axis. So that is the line y-axis. X is equal to 0, that's the y-axis. That is the line. Then the other one is y is equal to 0. Again, since they are also included, so we draw them as bold. Fine. And therefore, we need to shade the unwanted region. Going to shade the unwanted region. So x is equal to 0. So greater than 0. So any value of x greater than 0 to the right is included, and therefore we shade the other part. Then for the y is equal to 0, so y is greater or equal to 0, 0, and greater than, so above x-axis any value is greater than y, so it is required. So we shade the unwanted region which is below. Then from there I'm done with this. So again I plot this. The x-intercept is 8. x-intercept 8, and y-intercept is 12. So I take a ruler and join. For this case, we need to note that it is not, this line will be drawn as dotted since it is not included. 24 is not included, so we draw it as dotted. Then the other case, x-intercept is 9 and y-intercept is 9. So y-intercept is 9 and x-intercept, again in that case, it is 9. And therefore again for this case it is included, therefore we are going to draw a complete line. That is it. So for this one, this is 3x plus 2y is less than 24, and then the other one is 2x plus 2y is less than or equal to 18. Now we need to, let me use a point at the origin 0, 0. Below this line 0, 0, it is less than 24, and therefore we are going to shade this part. Then for the other one, again, this one we consider point below this line. It is easier to take the origin x0, y0, and therefore we substitute into this. We get 2 times 0 plus 2 times 0. 0 is less than 18 or equal to. So again, this is the required region, and therefore we shade this part. That is it. Now we have the required region. So the next step we need to do is to now, the question is, the workshop makes a profit of 6,000 shillings on each cupboard and 4,000 on each table. Find the number of cupboard and the number of tables that must be made for maximum profit, and hence determine the maximum profit. So in this case we need to determine the objective function for the optimization. So we get the objective function, which is of the form ax plus by is equal to k, whereby this will give the maximum profit or the optimization. So now for this objective function, now we are going to at least for the cupboard, for each cupboard, x represented cupboard and y represented tables, and therefore the objective function in this case will be 600 times x the total profit for the cupboards plus total profit for tables. Now we need to choose a point from the region of possibility. After that, we can get the initial value of k. After that, we are going to use a search line to find the maximum profit. So for this case, we get back to the graph. So if we just follow up on this, we can check to get where the maximum profit will be, since for x has the highest, and then for y the tables the lowest. So we expect where the value of x will be higher to give more than the y. So we can pick a point around this region, and afterwards we work it out. So which will give us an initial value of k. So I can choose a point along this area. I can try to choose point 21. So that I get the initial value. So choose a point 21. So let me put into this so that I get the value of k. So 6,000 times 2. 6,000 times 2. So here I've choose the point, 20. So plus, so I'll end up getting 12,000. Remember, I've just choose the point near the possibility, so you can either choose any other point. So now we have 6,000x plus 4,000, y will be equal to 12,000. So I can simplify, divide it through by 1,000. I have 6x plus 4y is equal to 12. Then divide it through by 2. I get 3x plus 2y is equal to 6. Now this is what I have, but simply I need to draw the search line. So this is our search line, and therefore let me simplify it. Divide it through by 12. So 6x over 12 plus 4y over 12 is equal to 1, and 12 over 12. So we get x over 2 plus y over 3 is equal to 1. So let me now draw this line. X-intercept is 2, y-intercept is 3. X-intercept is 2, y-intercept, that is it, y-intercept is 3. So that's the point. Therefore, I'm going to draw that search line. So that is it. So this is my search line. Once I do that, I'm going to use a ruler and a set square. I slide the set square, and I'm going to keep one edge parallel until the edge strike a visible region or point farthest from this line. Once I get the maximum value, That's what I'm going to choose. So let me take my ruler, and I have the protractor, I mean the set square, and then I'm going to slide along. So the other thing is this line here, it is dotted, so any point near this line is not included, and also a point here, it is not included since this line also passes there. So any point from this point, that will be acceptable, so where it will touch that edge. So we can see so we have this point here whereby x is 5 and y is 4, so that is the point farthest, so that is the point, and therefore so we have xy is 5, 4. So let us, this will give us the maximum profit, and therefore using the objective function get 600,000 x plus 400, 4,000 y. So this will be 6,000 times 5 plus 4,000 times 4. So here I get 30,000 plus 16,000, and therefore this will be 46,000. So this gives the maximum profit. The maximum profit. Question 22. The amount of money contributed by a group of students during a fundraising for a needy student was as shown in the table below. So this is the table shown, and therefore on the grid provided we are going to draw an ogive to represent the data. Then after that we are going to use the graph to estimate the median, also the quartile deviation, and the percentage number of students who contributed at least 750 and 50 cents shillings. So let us work this out. So for us to draw a ogive or cumulative frequency curve, we need to plot cumulative frequency against the upper class boundary, and therefore from the table we need to extend it and have a row for cumulative frequency. So we have here 2 plus 10, 12, 12 plus 12, we have 24, 24 plus 14, we have 24 plus 14, we have 38, then 38 plus 7, we have 45, 45 plus 3, that is 48, and finally 48 plus 2, that is 50. Then from there we need also since we are plotting cumulative frequency against the upper class boundary, so let us also extend this and have the upper class boundary for the classes. So below 0.301 we have the other class such that its upper class boundary will be 3 or 5, I mean 305. So here the upper class boundary, so 400 plus 401, we divide by 2. In this case we get 400.5. The other case will be 500.5. Then here we have the boundary, upper class boundary is 600.5. The other case is 700.5. Here we have 800.5. Then we have 900.5. And lastly here we have 1000.5. Therefore, let us draw the axis. Let me draw the x-axis and the y-axis. The same case we do with the x-axis. And since the values of the data has not started from 0, we can break the axis. Such that so this upper class boundary, and then the other part we have cumulative frequency. So for cumulative frequency it has gone up to 50, and therefore we can consider at least 2 big square to represent 10. So we have 10, 20, 30, 40, and 50. Then the other case, we can make the minimum value is 305, and the intervals is each is 100, 100, 100, and therefore can take this out, and this will be 300.5, then 400.5, 500.5, then 600.5, then 700.5, we have 800.5, then 900.5, and lastly 1000.5, since it has gone up to 1000. And therefore now we are going to plot the points, the cumulative frequency against the upper class boundary. So in the first case we have the lower class boundary of this first class, but this is the upper class boundary of the preceding class, and therefore its cumulative frequency will start from 0. Then 400.5, the cumulative frequency is 2. So the other thing we need to consider here, since one small square in this case, represent, so you can see from 0 to 10, there are 10 equal divisions, and therefore one small division represents there will be 10 divided by 10, so one small division represent 1, and therefore 400.5, the cumulative frequency is 2. So here is where we have 2. That's the mark. Then we have the other one, the 500.5. The cumulative frequency is 12. Cumulative frequency is 12. So this is where we have 12. So we have 0, 5, 10, 11, 12. So that's where we have it. Then for 600.5, cumulative frequency is 24. That is 24. 600.5, 24. Here we have 20, 21, 22, 20, 24. So that's where we have the mark. Then for 700.5, the cumulative frequency is 38, and therefore we have 30, then 35, 36, 37, 38. So that's where we have it. 800.5, cumulative frequency is 45. 45. So 45 is here. So that's where we have the mark. We put the mark. Then for 900.5, cumulative frequency is 48. 48. So 48. So this point. And lastly, for 1000.5, the cumulative frequency is 50. So here is where we have point. And therefore, after that, we are going to draw a smooth curve. So we are going to draw a smooth curve. That is it. Once we are done with that, now that is the Ogive. So from there, we are going to answer the question that follows. So we are going to use the graph to estimate the median. So for us to estimate the median, we need to get the median position. And in this case, there were 50 students. So median position is the middle value, n over 2, and that is 50 over 2, which is the 25th student. Now we need to get, for the median student, got how much in shillings. And therefore, we go back to the Ogive and we indicate the 25th. So here is where the 25th student lies, and therefore we draw a line. So let us draw a line which up to where it will touch the curve. Up to that point where it touches the curve. Then from there we move downwards. So it's at that middle part. So again, so we are going to read off this value at this particular point. It's actually in between this small box. And for that case, let us get the range from 500.5 to 600.5. The interval is 100. So 100 divided by 10 small boxes, that is 10. So that means one small box is representing 10. So half of it, it will be 5. So 600.5 plus 5. Therefore, the median value will be 6 or 5.5. So that is the median value. Then from there, we get the quartile deviation. For quartile deviation, to get the quartile deviation, that is to get the upper quartile Q3 minus lower quartile Q1 over 2. So the upper quartile Q3 is given by 3/4 of n. In our case, n is 50. So this is the of 50. This is the 37.5th student. So that's what we are going to determine from the graph. Again, for Q1, the lower quartile, it is a quarter of n. N is 50 in this case. So the 12.5th student, that's what we are going to look at. So let us get the upper quartile and the lower quartile. So let us locate that 7.5. That 7.5. So here we have each represent 1, 1. So that 5, that 6, that 7, that 7.5. So at this particular point, and therefore we are going to use a ruler. As it is there, draw a line until it touches the curve. Up to that point. Then again a vertical line. Vertical line. Now we read off this value. It's actually almost at the middle, and therefore one small box here represents 10, so half of it is 5, so 700.5 minus 5, so we are going to get, that will be 695.5. Then we also do for the lower quartile, the 12.5, so let us locate 12.5. So you have 10, 11, 12, so 12.5 there. Then again, then from there, so again, so this at the middle of this half small box, so 500.5 plus 5, we shall get, it is 5 or 5.5. Once we are done with that, now we can get the quartile deviation. Q3 is 695.5 minus Q1 is 505.5 divided by 2, and therefore 695.5 minus 505.5, that is 190 divided by 2. So we end up getting 95. Then lastly, the percentage number of students who contributed at least 750 shillings and 50 cents. So we need to at least locate 750 from the graph. So let us locate 750 from the graph and see how many students up to 750, how many students are there. So from the graph, 700, 750. So from this point up to here it is 750, 750. So from here we add 50. So 750 and 50 cents at that particular point. So we are going to draw a line up to where it touches the curve. So that's where we have 7. So up to that point. So you can see it touches the curve at this particular point. And at that particular point, the number of students the number of students. So the number of students is 42. So at this point it is 42. But the question is the percentage number of students who contributed at least. So it is 750 shillings and 50 cents and above. So here we have 42. So it will be 50 minus 42 plus 1, because also the 42 person is included. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is, we have, so for 50, at 50, 750 and 50 cents is approximately 42 students. And therefore we start from this counting. So also that is included. So the number of students who contributed this amount and above, 50 minus 42 plus 1, and therefore we get 9 students. So percentage number of students, percentage, so we have 9 and there are a total of 50 students times 100. So we work it out, we get 18%. So that's how we solve this particular question on cumulative frequency curve, or the Ogive. So question number 23, in the figure below, vector OA is equal to A, vector OB is equal to B vector, and BX meets OY at C. OX to the ratio of OA is 1 is to 2, and BY to the ratio of Y is to YA is equal to 1 is to 3. And therefore, we are required to express in terms of A vector and B vector, that is BA vector, OY vector, and then BX vector. And from there, given that OC is equal to HOY and BC is equal to KBX, determine the values of H and K. So for this vector question, we have been given that OA is A vector, then OB is B vector, and BX, we have BX meets OY at point C such that OX, the ratio of OX and OA is 1:2. So in that case, so from O to A there are two parts, and therefore that is 1 x and OA, so it has two parts. And therefore BY, so we have BY to the ratio of YA is 1:3. Then from there we can express in terms of A vector and B vector, that is BA. So we have BA. So to move from point B to A, we can pass through BO, then OA. That is, can pass through BO plus OA. And in that case, BO, we are moving in the opposite direction, so that will be minus B vector. Then for OA, we are moving in the positive direction, that is plus A vector. Or you can rewrite it as A vector minus B vector. Then for OY, so from point OY, we can move through either OB, then BY, such that this will be, so we can move, instead of passing through OY directly, we can pass through OB vector, then plus BY. And something else we needed to note that about BY is 1 out of 4 parts of BA. So that's what we need to know. And therefore, here OB is B vector plus BY is a quarter of BA, and part Roman 1 we got BA, so that will be quarter of BA, which is minus B vector plus A vector. So we open the bracket, we have B vector minus a quarter B vector plus a quarter A vector. So we can simplify this. B vector minus a quarter B vector, that is 3/4 B vector plus a quarter A vector. Or you can simplify and it will become a quarter of A vector plus 3B vector. Either of those answers is acceptable. Then we need to get Bx. So vector Bx, from B to X, we can pass through BO, then OX. So that is, can pass through BO, then plus OX. And therefore, BO is minus B vector. We are moving in the opposite direction, and therefore direction is very important. Plus OX is a half of OA, and OA is A vector. So this could also be written as, or a half A vector minus B vector. We proceed on to the other part. Given that OC is equal to HOY and BC is equal to kbx, determine the values of h and k. So in this case, we need to write OC in two different ways. So we are going to write OC in two different ways, and therefore the first one, OC, can be written in terms of OC k of OY, I mean that is h of OY, and therefore h OY, we got it in our first case in Roman 2, OY, that is the same as a quarter A, so we can consider this. So we can write it as a quarter of A vector plus 3/4 of B vector. So we can open the bracket, and therefore we shall have a quarter H A vector plus 3/4 of H B vector. So call this the first equation. Again, we are going to rewrite OC in another way. So OC, we can pass through, instead of passing directly from O to C, we can pass through OB, then BC. OB vector plus BC vector. OB is B vector plus BC, you have been given it is K of BX, it is K of BX, and BX in this case, it is, we have minus B vector plus a half A vector. So we work it out, we shall get, so this is B vector, open the bracket, K times minus B vector, that is plus KB vector, then this is minus, then we have plus a half K A vector. So this is, we can factor out B vector, which is common, so we shall have 1 minus K to bracket B vector plus a half K A vector. Allow me to rewrite it another way, beginning with A vector, so that will be a half K of A vector plus 1 minus K into bracket B vector. So call this the second equation. And therefore, we are going to equate the two. Since the two are equal, therefore we are going to equate the corresponding terms. The coefficient of A vector, that is a quarter H, is equal to the coefficient of A vector, it is a half K. And therefore, this implies that H will be equal to a half K times 4, and therefore we get H is equal to, this is 2K. Then from there again, we are going to equate the coefficient of B vector, so we have 3/4 of H is equal to 1 minus K. But here we have the value of H in terms of K. So where we have H, substitute with the 2K. So that is 3/4 times 2K is equal to 1 minus K. So here by 2, 1 by 2, 2. So I have 3 over 2K. Then from the other side, plus K will be equal to 1. So 3 over 2K plus K, that will be equal to, this will give us 5 over 2K is equal to 1. And therefore K will be equal, multiply both sides by 2 over K, so K will be equal to 2 over 5. Therefore we can get H is equal to 2 times k, and k is 2 over 5, which is 4 over 5. So those are the two values of h and k. So k is 2 over 5 and h is 4 over 5. So next is question number 24. A trapezium PQRS with vertices P 2, 2, Q is 6, 2, and R is 6, 4, and S is 2, 8 is mapped onto P prime, Q prime, R prime, S prime by a transformation matrix, which is minus 1, 0, 0, 1. So find the coordinates of P prime, Q prime, R prime, S prime. Then from there, on the grid provided, we are going to draw that quadrilateral PQRS, that is a trapezium, and its image. Then after that, we also answer the question that will follow. We are going to find the second image of the first image under the transformation matrix, this matrix. After that, on the grid, again we are going to draw the second image. After that, we find a single matrix that will map the second image onto the first image. So let us begin working out. So we have the trapezium PQRS is mapped to its image by this transformation matrix, and therefore we need to get also the coordinates of the image of this trapezium, and therefore the transformation matrix, which is minus 1, 0, and 0, 1, multiplied by the object matrix, so P, Q, R, S. So P is 2, 2, Q is 6, 2, R is 6, 2, and S is 2, 8. So we multiply, we are going to get the coordinates of the image P prime, Q prime, R prime, and S prime. So let us multiply the matrices. So first row, first column, so minus 1 times 2 plus 0 times 2, so I get minus 2. Then to get the coordinate of this point here, I have first row multiplied by second column. So minus 1 times 6, that is minus 6, plus 0 times 2, so we end up getting minus 6. Then to get the element of this part here, so multiply the first row, that column, so minus 1 times 6 plus 0 times 2, we get minus 6. Then the element at this particular point will be first row, fourth column, minus 1 times 2, that is minus 2 times 0 plus 0 times 8, so we get minus 2. Then to get the element in the second row, first column, multiply the second row, first column, so 0 times 2, 0 plus 1 times 2, we get 2. Then the other one is 0 times 6 plus 1 times 2, get 2. The element in this point, we multiply second row, that column, so 0 times 6, that is 0, plus 1 times 2, we have 2. then from there, so actually in our case this was 4, that was 4, so this is 4, and here now I need to correct it. So I think that is the correction we have to make. So we have 0 times 6, 0, plus 1 times 4, that is 4. Then to get the element in this part is 0 times 2 plus 1 times 8, we get 8. Therefore the coordinates, so P prime, it is minus 2, 2. Remember I write in the form x, y. So these elements here represent the x coordinate, these represent the y coordinates. And therefore Q prime is minus 6, 2. Then R prime is minus 6, 4. And then S prime is minus 2, 8. Once we are done with that, now on the grid provided, we can draw the trapezium PQRS and its image. So therefore, I needed to make a drawing, and therefore for that case, first I needed to consider the maximum value of x and y. So for x, I consider both the image and the object. So for x, the maximum value will at least go up to 6. For y, for minimum value of y, again at least to minus 6. Then for y, the maximum value will at least go up to 8, and the minimum value will at least go up to 0. But remember, this is a transformation, so at least it can go up to minus 5, both sides. And therefore, let us draw the axes. So let us draw those axes, and then from there, proceed. So let me now draw the same case applies to the axis. So from here, at least I can have up to 8, then 7, 6, 5, 4, 3, 2, 1, and then 0 will pass at this point here. So here we have now 0, minus 1, minus 2, minus 3, minus 4, minus 5, until up to minus 6. The same case applies to the other one -1, -2, -3, -4, -5, -6. Then we have 1, 2, 3, 4, 5, 6, 7, 8. That's okay now. Then let us now plot the points. So for P it is 2, 2. P it is 2, 2. X is 2, Y 2. So point P is there. Then we have Q is 6, 2. Q is 6, 2. So you have 6, 2. So here is where point Q is. Then we have R is 6, 4, 6, 4, 6, 4. So that's where we have R. Then we have S is 2, 8, 2, 8, 2, 8. We move upwards. So S is there. Then again we use now ruler to join the points. So from P to Q, then Q to R, then R to S, then S to P. So that is it. So that is the object, and therefore also we need to again draw the image. So P prime is -2, -2, 2, P prime. Then Q prime is -6, 2, -6, 2. So that's where we have Q prime. Then R prime is -6, 4, -6, 4. So that's where we have -6, 4. Then S prime is -2, 8, -2, 8. So that's where we have S prime. Again we join points Q prime to P prime. Then this is R prime. Then R prime to S prime. Then S prime to P prime. So that is it. Then from there now we have drawn the object and the image, and therefore we need to move on and answer the other particular part of the question. For the other part of the question, now we are going to find P double prime Q double prime R double prime S double prime, the image of P prime Q prime R prime S prime under this transformation matrix N, which is -1/2, 0, 0, -1/2. Therefore again, whatever we are going to do, we write the transformation matrix multiplied by the, now this case, the first image becomes the object of the second image, and therefore P prime, R prime, Q prime, R prime, S prime. So P prime is minus 2, 2, Q prime is minus 6, 2. We got previously in part A. Then R prime is minus 6, 4, and S prime is minus 2, 8. So if you multiply, we shall be able to get the image P double prime, Q double prime, R double prime, S double prime. And therefore, do the same. Now, first row, first column minus a half times minus 2, that is minus positive 1 plus 0 times 2, 0. So we have positive 1. Then to get the element, we have minus a half times minus 6, that is 3. 3 times plus 0 times 2, we get 3. Then the other element we get by multiplying first row, that column, so minus a half times minus 6, that is 3 plus 0 times 4, so we get 3. Then the other element is first row, fourth column, minus a half times minus 2, that is 1, plus 0 times 8, we get 1. Then the other element in the first, second row, first column, so 0 times minus 2, 0 plus minus 2, minus a half times 2, we get minus a half. Then 0 times minus 6, 0 plus negative a half times 2, we have negative 1. Then the other element will be 0 times minus 6, 0 plus negative a half times 4, we get negative 2. Then the other element, second row, fourth column, 0 times minus 2, 0 plus minus a half times 8, we have minus 4. So therefore in this case, P double prime is 1 minus 1, Q double prime is 3 minus 1, R double prime is 3 minus 2, and S double prime is 1 minus 4. Therefore, we need to draw this image on the grid. So we plot point P double prime, 1 minus 1, P is 1 minus 1, 1 minus 1, we have 1 minus 1, so P is there. Then Q double prime is 3 minus 1, so 3 minus 1, so we have 3 minus 1, so that's where we have Q double prime. Then again R double prime is 3 minus 2, 3 minus 2, 3 minus 2, that is R double prime. Then S double prime is 1 minus 4, 1 minus 4, so we have 1 minus 4 at this particular point, S double prime. Then we join P double prime to Q double prime, then Q double prime to R double prime, then R double prime to S double prime. And lastly, S double prime to P double prime. So from there now, we have drawn the second image. And therefore, part D of the question, we are done with this. So we are looking at part D of the question. Find a single matrix that maps this point back to. So we need to find that single matrix. Let us call that single matrix A, B, C, D, that will map back this P double prime, Q double prime, R double prime, S double prime, back to I don't require to write those coordinates, but now, since now we are moving the reverse way, we needed to find the inverse of this matrix. Since this is the transformation matrix that mapped the first image to the second image, and therefore now it's the second image back to the first image, and therefore we needed to find the inverse of matrix N. So that's actually what we need to find. The inverse of matrix N will be given by 1 over the determinant of N, and then we are going to interchange these elements in the main diagonal. That will still remain as minus a half, minus a half. Again, we reverse the sign. So 0 will still remain to be 0, 0. And therefore, let us get the determinant of N. So multiply the elements in the main diagonal, negative a half times negative a half, then minus product of element in the other diagonal. So here we end up getting a quarter. And therefore, now back to the single matrix. So inverse of N will be 1 over the determinant is a quarter. Then we have minus a half, 0, 0, minus a half. So this will translate to 1 divided by a quarter, we get 4. Then minus a half, 0, 0, minus a half. So multiply each element by this scalar. So 4 times negative a half, that is 2. I mean negative 2. Then 4 times 0, that is 0. 4 times 0, 0. 4 times negative a half, we have minus 2. So this is the transformation matrix that will map the second image back to the first image. Then finally describe fully the transformation that maps the second image back onto the first image. So let us go back to the grid and we look at it. So now what we need to have is the transformation that maps the second image. This is our second image back to the first image. So we can consider the corresponding points P prime and P double prime, and the same case applies with the other one. So for this case now, I'll consider I'm going to draw a line. So P prime to P double prime, can see it is passing through the origin. If I were to draw a line there, it passes through the origin. The same case applies with S double prime and S prime. Again, passes through the origin. Passes through the origin. The same case will apply even to the other points Q prime and Q double prime. Again, to follow the same trend, and therefore Here we can say there is an enlargement, and therefore, since it is an enlargement, we need to find the scale factor. Since it is an enlargement, we need to find the scale factor. And therefore, so first we say it is enlargement, that is an enlargement. Center is the origin 0, 0. And therefore, let us get the scale factor. Scale factor from the origin, we can get OP. So mapping what? So whatever we are mapping, it is this back to this. So P prime, and therefore that will be scale factor. So the image distance over the object distance from the center of enlargement. So for this case, I'll consider OP prime over OP double prime. Since in our case here, P double prime Q, this is the object and this is the image. So we are getting image distance over the object distance. So I'll consider the coordinates. For the coordinates, we can see in this case from the origin it is -2 or 2. So let me consider for the x coordinate -2. I have -2, that distance -2. Object distance is object distance in the x direction. From here it is +1. And therefore the scale factor is -2, since it is mapped on the opposite side of the axis.